Hello folks, welcome back to my new channel. In the last video titled Road to MLOps, I gave you an introduction to MLOps and we looked at the different concepts and different components basically that form part of an ML workflow. We also compared it to DevOps and we understood what are the new challenges that come in when you introduce ML models, like machine learning models, on top of the usual software development code that we have. So in this video, what you're going to do is we're going to translate those concepts into concrete stack components. Right? So what is a stack component? I tell that in the context of having a tech stack for your ML workflow. So whatever tech stack you use, what are the components, what are the tools that you use for each of these different stack components. Right, so we'll also take a look at some common tools in the industry that are used for these stack components. We won't go into details for them right now. Maybe in future videos we'll have a more deep dive into each of the stack components, but for now we'll only look at the landscape. We'll figure out how the landscape looks like and then we go from there, right? So without wasting more time, let's jump into the whiteboard. So I already have the diagram ready from the previous video. So for those of you who might have watched it, you must be familiar with that. But for those who haven't, I'll just go over them really fast to give you an understanding of what it looks like. So here, each of these different boxes or ovals are different stages of an ML workflow. So you have data, you have model, and you can notice that each of them also have some kind of points listed down there. So for example, data, you need versioning, you need experiment tracking. So we discussed all of this in the previous video and we'll be going over them again when I discuss the stack components. So I won't be stressing too much over the details again right now. So let's start with the first one. Okay, so we need data versioning, right? So you already know why data versioning is important, right? So how exactly do data version? So you need some kind of a stack component. So you need to have some tool in your ML workflow that is responsible for actually tracking your data, right? So maybe I'll draw just a huge box here. So that is some kind of data versioner, right? Please forgive my handwriting here. All right. So what are the responsibilities for data versioner? So in this case, it needs to track data, right? It needs to track all new data that comes in. It needs to make the data available on demand, right? For example, if you have some kind of version data, need to access it from some other project. So you need to have that available on demand, right? You need to track data, track changes also included in that particular point. So all of these things should be a part of something that works like Git, right? So Git is what we use for tracking software code changes, right? So, but we can't do that for data because data is huge and there's multiple things to be tracked. So we need some kind of an alternative for Git, and that's what data version essentially does, right? So these are some of the things that you need, and some common examples in this particular stack component could be DVC. So that is a really popular open source tool that you can use. We'll also be going over them. It's really interesting to actually check this out. And Neptune is also, you can use it for versioning data. And like if you go into some similar concepts, there's also something called a feature store, right? So what is a feature store? So let me draw a box here which says feature store, right? You might have heard about it, but let me just, it's important to actually notice the difference between different stack components and what are their responsibilities and do they overlap or not, and what to choose, right, when you're actually building your own MLOps stack. So in terms of the responsibilities of feature store, it's also something similar. So inherently it also does data versioning, like some of the tools like Feast is also feature store. It does data versioning itself, like not exactly data but features. So what exactly does a feature store do? It takes your input from some kind of data source, whatever data source you have, right? And then it tries to translate that into features. For example, when you're trying to train an ML model, you don't train on raw data. You transform that data into some kind of useful features, right? So that is something that feature store is responsible for. So you define your logic there, and then it doesn't have its own database. Basically, it uses your own database, whatever database you have. But then it performs these computations on it, and then it is responsible for serving these features to training, and also when you're actually serving your models in inference. Right, so that is what a feature store does. And some feature store also do data versioning inherently, as I told you, for example, Feast, right? So it would make sense to you to only use a feature store and not a data versioning component when you're actually doing it. So you don't need to have both of these stack components inside your stack, right? So either or. So either use a data versioner in some simple cases, or if you have lots of features, lots of data that comes in and you want to track those things, then maybe go with a feature store, right? So that is the difference between a feature store and a data versioner. So yeah, so these two components broadly cover the need for versioning of data, right? That is what the overall aim is. So we should keep looking at the big picture and then comparing what the stack components actually try to achieve. Alright, so data versioner is completed, feature store is there. Now, like, I'll be going into more details later on, so I won't be stressing over much because we have a lot to cover here. So if you have some doubts, either reach out in the comments or you can try to explore this on your own or wait for the specific video to come out. So yeah, that is the idea. So data versioner is there, feature store is there. Both of these help you in actually controlling your data, versioning your data, and then making them available on demand whenever you require it. Right, that is the idea behind the data scene. Now, the next thing which you notice on the diagram here, it says experiment tracking. Right, so experiment tracking in itself is a much broader concept than just covering the input data. Right, so it's written over here in the first section, but actually it covers almost the entire workflow. What exactly is experiment tracking? So experiment tracking is something that tracks all of your hyperparameters or whatever variables that you're using throughout your workflow. So you might imagine a common workflow to be like you choose some values for say learning rate and some other stuff, and then you perform a training, and then you're not satisfied with the results. So you do some modifications to the parameters, you change the value of alpha or something else, and then you do another training. So how exactly do you track all of these changes? So if you do track these changes, it's really helpful because you can then go back and understand, okay, maybe these set of values were really beneficial for the model. Like this is when I got the highest accuracy, right? So all of these things can be tracked over multiple experiments that you perform. That is why an experiment tracker is really important. So let me also draw a component box here which says experiment tracker. Really crucial for your ML workflow, right? And now, as I told you already, the main responsibilities of this would be to track all parameters, right? So that is one of the things that it needs to do. And then maybe optionally track your model itself. So whatever trained model you have, you can also track it using an experiment tracker, right? And then tracking outputs like accuracy, all of that stuff also falls in the context of parameters, but let's also make it really explicit here. All right. So again, if you look at this component itself, it has multiple responsibilities, right? It tracks parameters, tracks models, tracks outputs. And now some of these might also overlap with other stack components, just like what we had with the feature store and data versioner. So tracking model in itself can also be a part of something called a model registry. So if you have something like, say, a store for only your models, so I'll draw this model registry box here. Right, so this stack component itself can be a specialized storage system that basically stores your models and all related dependencies in some files along with it, and it loads them when you need it. So that is the idea behind a model registry. We'll also talk about that more when we go to the artifact store and other components. So, but I'll just give you an introduction here in the context of an experiment tracker. So that can also be used to track your models, right? So again, there's some overlap between these two components, and it's up to you to choose between what kind of complexity you're dealing with in your workflow, and then choose any of these components to go with. Coming back to the experiment tracker, let's also look at some examples here. So you can have, say, MLflow. You probably heard of this. MLflow is a really nice experiment tracker, and it usually has also a UI that comes with it, which you can use to go through each of your instances, each of your experiments. So really handy there. There's also weights and biases, right? So weights and biases is also really popular. 1dB. You can also use that for pretty much similar things. And like for more comparisons between these tools and how they work, like that will be covered in future videos, not here. So yeah, this is the experiment tracker. Now let's go back to the diagram that we had earlier. So we have covered versioning, we have covered experiment tracking, and we have also discussed some of the overlap that exists between different stack components, right? Now let's look at the model side of things. So we come to the model. We need model training. We need the ability to actually train models, right? So that needs to happen on some kind of compute. And by compute, I mean any compute resources like your own local system, your cloud machines, VMs. So on any of these things are required in your stack component. It needs to be a stack component in your stack that actually performs the training, right? With whatever resources you want. So you might want GPUs for some particular training. You want some more RAM, and all of those requirements need to be satisfied by this stack component. So here what I'll do is I'll change the color first of my pen. Oh no, that's wrong. It shouldn't have happened. Anyways, I'll change that color, and now let's draw another stack component here. So this is going to be, say, I'll just call it a compute environment right now. I don't have a better name. ZenML calls it a step operator, and I'll tell you what ZenML is later on, but I'm just giving you a heads up. So a compute environment, or anything that you want to call it, like we're not going over names here exactly. So this can be something that runs your trainings on, you can run your trainings on these things, right? It provides CPU and GPU to you and any other resource that you want. So this needs to be on demand. So you must specify, okay, what exactly, how many CPUs, how many GPUs you need for your training and stuff, right? And it needs to have some kind of logging, right, which actually allows you to see what's going on. So if you're doing it remotely, you need to have access to the logs of how exactly the training is going on, how much time is left, all that stuff needs to be there as well. So some common examples for this thing could be really simple. You can either have a VM that does it for you, right? Maybe an EC2 instance. You can have a Kubernetes cluster exactly to actually help you with that. So it's really broad set of tools that you can use for here. You can also use specialized platforms like Azure ML. So it's Azure's Microsoft Azure serving for machine learning models. You also can use AWS's SageMaker or Vertex AI. All of that things, all of those tools can be easily used for training your models, right? So that is also part of the compute environment. Now, yeah, if you look at the stack right now, you can see you have an experiment tracker, you have a data version, you have a feature store, you have a compute environment, which is really important to actually go about training your model. Yeah, so now let's talk about validations. So the first thing I do is, again, let me change my color to blue. And yeah, it mentions here automated validations, and it says supply correct data, ensure right pre-processing. Again, this is really vague and not easy to understand. So we'll expand on the concept of data validation. In the context of training your model, right, so you have to make sure that data that you supply to your model is of good quality and it conforms to the rules that you set for your data, right? So you maybe have some kind of restrictions or some kind of peculiar rules in place which you check for before actually sending it to the model, right? So all of those rules are enforced by a component called the data validator. So I'll just draw a box here for data validation quickly, right? And now let's discuss the responsibilities for such a component. So as already we discussed here, the first step should be checking for data integrity, right? So that is really crucial. The next thing is checking for a concept called data drift. For those unfamiliar with this, it means usually a change in distribution of your data between two different stages of ML workflow. For example, if you're training your data with some data, if you're training your model with some data of a particular distribution, and when you're actually serving the model, the data which you send to the model is not different or has different distribution, the results will be different, of course, right? So you have to make sure that data drift doesn't happen, and data drift is actually happening. In that case, you have to retrain your model, right? So all of those things are handled by something called data validators. Now, some of these components, some of the tools that we're going to use for data validators also support checking for, also involve the model basically. It also checks for the model drift. So it's also a new concept for those who haven't heard of it. So model drift is also a part of some of the components. For example, deep checks I think also has integration for involving the models with validations. So again, this is a really important concept, and it's really useful stack component when it comes to making sure a model is performing really well, because ultimately data is at the heart of your model and its training as well. Okay, so the next step in the process is deployment, which makes sense because once your model has trained and now it hits certain thresholds that you have set, it's time to actually deploy it at some endpoints that can be consumed by applications, and so other people can also make use of the model, right? So deployment, and let's first draw the stack command, because it's certainly a stack command that we need in our stack. So there needs to be some kind of a model deployer. I'll just call it a model deployer here. You can call it anything you want, as I said. Now the responsibilities for such a component would be first to allow you to serve your model and serve requests in real time or in batch mode, right? So either offline or online inference. So what I mean by that is either you can send a request one by one to your model to be inferred, or you can send them and not expect result immediately back. So you can just send them, the model then batches them together, the model service batches them together, and then all of those are processed together. So you can usually handle a large amount of requests in this way. So the model deployer needs to support either real time, actually both, yeah, the real time and batch processing. So an ideal model deployer should be capable of doing that, right? So that is one of the things. Other thing is it needs to have support for custom pre and post processing. So usually when you serve your models, you don't just serve the model file, you serve some code along with it. And this code is responsible for actually running some kind of validation, so some kind of pre-processing to the request that comes in, or some kind of post-processing to the results that the model produces, right? So there needs to be some support for pre and post processing, right? So there needs to be support for adding your code along with your model. So serving not just the model, but the code along with it. There needs to be also integration with your model registry, right? Because that's something which is really obvious, because there needs to be some connection between your deployer and the model registry. And this also allows for concepts like continuous deployment to take place, because you might want to maybe have some kind of triggers in place that whenever a new model comes into the model registry, you just automatically deploy it. So all of those things form a part of model deployers, right? So that is something you also need integration with, support for such things, right? So model deployers are some of the examples could be, say, Selden core. Selden is a really nice model deployer. There can also be kserv, which was earlier KF serving, if you remember that. So KF serving, kserv, Selden core. So all of these components are really helpful when it comes to model deployers. There are more, but we'll talk about that later on when we specifically cover model deployers, right? So that is model deployment. And now the next thing which comes in, if you look at the diagram again above, let's see, is maintenance and monitoring. So monitoring the model in deployment is also very important, because multiple things can go wrong once you are in deployment. You have to maybe first check for the training and the serving data are the same or not. So do they have the same distribution? We already mentioned about data drift. So if the data changes, then the outputs of the model will also change. So you have to check for that. Then again, you also have to check for, say, is the data which comes into your inference service in the right format, is in the right schema, right? So that also needs to be validated before you actually serve your request. Otherwise, it will again lead to some unexpected results. So you also have to check for stuff like, is the model aging? So has the model parameters really went out of date? And that is something also needs to be checked in some kind of monitoring systems. So that, and along with that comes the infrastructure side. So how much resources are you consuming? So is there something which can be spun down? Is there something which can be conserved? Or are the instances running in the perfect health conditions? So all of these form a part of the monitoring component's responsibilities, right? So these things in itself could be solved by some of the other components that we discussed so far, right? So data validations can cover checks for, say, the right formatting or the data drift, as we mentioned already. So all of these things could be handled by different components, but we can also have a dedicated component which actually does, say, infrastructure side of things, and plus some other stuff which is left out by other components. So again, this is a place where you have some overlap between responsibilities between different stack components, and it comes to you to actually figure out if you need to have a dedicated monitoring component, or could you also work with different stack components which you already have, and then that suffices for you. So it is up to you as a user for determining how exactly you need to design your stack. Okay, so some examples for monitoring components could be Prometheus, along with maybe Grafana, because Grafana adds a dashboard to you. Then you have maybe TensorBoard. So TensorBoard can also be paired with Kubeflow. So when you run your pipelines in Kubeflow, you can also check out visualizations using TensorBoard. There are some other visualizers, open source visualizers, for example, Dash. Maybe you can use that to design some kind of UI around your app data. So monitoring components can be multiple and also really important, really crucial part of your ML workflow. Now, if you look at the entire section that I have here, you have multiple stack components. So you have covered data validators, data versioners, experiment tracker, deployment, feature store, registry. So there's something which is missing from here, right? How do these different steps connect to each other? Right? So how does a model get data from data versioner, right? So there needs to be some kind of communication links between these things. And where exactly do you store your data, right? Where exactly do each of these artifacts get stored? So that is where the artifact store comes in. So I'll just mention with a random color here. Maybe let's go with gray. Yeah, why not? Or green, maybe dark green. Yeah. So this is an artifact store. So an artifact store is responsible for actually storing all your artifacts across different pipeline stages. So all of these steps can read and write to this artifact store, right? And that is the common link between these different steps. So you don't need to worry about how exactly this happens. So maybe we can talk about that later on. But artifact store in general is responsible for storing all of your artifacts, storing all artifacts related to your model training, right? And being available to all components which need this data, right? That is important. And now some forms of specialized artifact stores could be the model registry. So there's again overlap between this. So you can either keep your model in an artifact store, or you can have a dedicated model registry for it, right? So you can think of model registry as a specialized artifact store as well, right? So that is the idea behind an artifact store, and it usually acts as a link between different components, as I told you, right? Now some examples for artifact store, it can be multiple things. You can have any cloud storage, for example, S3 bucket, or you can have, say, Azure's blob storage, or a Google container bucket, sorry, Google storage bucket, sorry. Yeah, so all of these are good examples of an artifact. You can also have a local artifact store if you want, so you can have it on your own machine. Right, so these are some of the examples for artifact stores. All right, so it seems like we have a complete stack, but there's another component which is missing, and which is the place where you actually run the code to define the relations between these components, right? So where do you actually say, okay, this is my pipeline, these are the components that I'm going to use, and these are the steps which I need to be part of the pipeline. And such an environment is what I call an orchestrator. So an orchestrator is essentially a component which orchestrates your training, orchestrates every other task that you want to perform here, right? So it is responsible for, so first let me just draw a box for orchestrators here. So we'll do it in red here. So there you go, orchestrator. I'll draw a big box here. So an orchestrator is responsible for actually executing the code that links all of these components together, right? So yeah, that is one of the things. Now this orchestrator also is the place from where you submit your jobs to the compute environment, to connect to the artifact store. All of these are part of the orchestrator. So you can either use a local machine as an orchestrator. Obviously you can run your pipelines on your machine, and then this pipeline or running on your machine can communicate with your compute environment, be it on Kubernetes cluster somewhere, or you can get to your artifact store, which is maybe on S3 some other place. So an orchestrator could be a local orchestrator, so it can run on your own machine. It could be also on the cloud, like a Kubernetes cluster or some other components, right? So you can also use, say, Kubernetes for the same job. So orchestrator in itself, if you are clear with the idea, it is used to define the pipeline, run the pipeline, and then this pipeline can communicate with other components of the stack, right? So this is what it means this is what you mean when you say you're orchestrating a pipeline. All right, so now if you look at this entire workspace that we have here, you can see there are multiple components, and each of these components performs some of the other responsibilities when it comes to ML workflows needs. All right, so now just to put it in more context and to make you understand what we have achieved so far, let us also go into one of the papers, really popular papers, which got published some time back. So this is a paper which has a lot of different concepts about MLOps. You can easily, I'll put a link there in the description. You can check this out. It has a lot of good things about MLOps, and really serves as a way of reference to actually know more about each of these different components. And if you look here, if I zoom in here, if you look at these components which I mentioned here, you can find a lot of similarity between what we've discussed and what you see here, right? So you have like a source code repository, right? So that is responsible for actually versioning your data, versioning your model, versioning your code. So all of that is handled by a source code repository. There's a CI/CD component, there's a model training infrastructure, what we call the compute environment or the step operators, right? You have an orchestration component, sorry, that is responsible for orchestrating a pipeline. You have a model registry, you have a monitoring component, you have a model serving component, feature stores as you mentioned, and there's also a metadata store. So what exactly is a metadata store? So we haven't talked about that yet. So that is something which actually tracks all information about your pipeline. So where exactly is the location of a particular artifact in artifact store? Like what is the URI for that? That has to be part of metadata store. How exactly are your parameters being tracked? Where are the parameters being tracked? So all of that also becomes a part of the metadata store. So it handles all kinds of information in some database about your pipelines, right? So most of the tools come in built with metadata stores, so you don't have to worry about setting those up, right? So this is also a really important concept when it comes to almost all machine learning pipelines do have a metadata store which actually holds information about the entire process, right? So this is, so you can see we have covered almost everything here, and this is another website I want you to see, yeah, and that's the ZenML's documentation. So you can see you have multiple MLOps tools here. So you have Orchestrator, you have artifact store, a metadata store, container registry, secrets manager. So it has really good documentation about each of these different components, and you can easily go into any of them and you have good explainers about what these components are. You also have some examples of what tools you can use and what are the benefits and pros and cons. So actually this is really good learning material if you want to actually explore each of these components more. We'll be also following these a bit more in detail when you go to each of these different components in deep dives. Alright, so these are two components I'll put a link to in the description. You can check those out, really good for understanding more and building upon what we learned in this video. So that's all I think, and I'll see you in the next video where we deep dive into each of these components. We'll be starting with data validators, and I really hope you enjoyed this video. I really hope it was helpful to you, and let me know in the comments if you have any questions, if you want any more information on any of these components, and if I missed any components, let me know as well. So that's all. I'll see you guys later. Thank you so much for watching. Bye bye.